Hey guys, I'm sure the rise of vision language models has been taken in many different tones over the last month. We have continuously seen launches of unique vision language models by developers, starting from QnVL models to Pixtral to Llama 3.2. One such opinion that seems to resonate is, okay, so what? Now we can ask the chatbot to answer questions about an image. Google Lens did that ages ago. A thought that can very easily be tested if it stands true. So in this video, we are going to be looking how you can easily integrate such VLMs in applications, what real life problems you can solve with them, what expense you are looking at deploying such a system, and finally how you can choose the best VLM for your use case. Stick around till the end because we find some fascinating behaviors from GPT on very simple vision tasks. But before we dive into all that, I make weekly content about LLMs, VLMs, GenAI, and all the operations surrounding them. So if you are interested in thorough tutorials, breakdowns, benchmarking, and capture all of them in a nice digestible format and pace, please go ahead and subscribe to my channel as it helps me a lot. Let us start by seeing how you can easily integrate VLMs in your application pipeline using Python code. We are going to source all of our models from Tune Studio. This free GenAI platform lets you access a plethora of SOTA, LLMs and VLMs through API calls for tasks such as text and vision completion and even deeper applications of GenAI like AI assistants. First, to understand the final product we are trying to make, we are going to be making a Streamlit application that lets users upload an image, ask a question about it, choose the VLMs they want to use for inference and comparison, and finally choose the response that best satisfied the query. This application is a part of my ongoing endeavor to make a thorough Q&A dataset for benchmarking VLMs, the first of which SynCap Flickr 8K was released last week, so go ahead and check that out. As for the code, first we are going to declare a custom function for the VLM calls. Then we shall code the Streamlit UI, which should include all the bells and whistles like picture upload, question yield, and up-down menus for the models. Using the custom function, we will declare a function to generate responses. This function should also let us measure the latency of the responses and the token used by each model. Which should let us judge how expensive these models are. Finally, there is a small function to save the responses as a CSV. This model specifically ensures that the current state of variables in the application allows you to properly append an existing CSV file with the results. Now, let us look at some of the initial experiments I've done for VLMs for the following categories: medical image QA, retail and e-commerce, surveillance, and art. These categories target the intended assistant uses of VLMs, more specifically questions that you're likely to ask Siri daily, barring the first scientific experiment, which shall judge the model's ability for medical inferencing. Medical imaging is one of the benchmarking giants that VLMs are often fine-tuned to, due to their potential applications in diagnosis, research aid in general. Some interesting inferences that I was able to observe while doing so were: this is a question asking the model to check out an MRI to identify a certain sector of the brain. Both Llama 3.2 and GPT4o came up with the right answer. However, GPT4o's response was somehow thorough in this very restricted option-only question. In the second case, I asked both models to interpret a rhythm and suggest a possible source. GPT4o easily understood that the rhythm came from atria, which is a rather important diagnosis task. Atrial arrhythmia or abnormal pulses in the atria are severe cardiac conditions. Both cases showed that GPT4o, with its vast knowledge, outperforms Llama 3.2 regarding more technical and scientific tasks. Although coming close in terms of choosing the right option, GPT4o responses were better able to explain the image and answer the queries. Second task that I tested the model on was retail and e-commerce tasks. Tasks usually involved with assistants deployed on e-commerce platforms like Amazon, aiding sellers' ability to answer queries and better explain their products automatically. Some interesting inferences for this task were this image, which was taken from H&M collection, and asking the models to tell me about the different animals on this jacket. GPT4o was easily able to identify the animals despite their abstract nature. It is to be noted though, due to Llama 3.2 being trained as the next big Facebook/Instagram update, it is more likely to focus on the multilingual abilities when being asked to answer a query based on an image. One daily task, mostly Americans struggle with, is temperature units while washing your favorite shirt. Well, go ahead, ask your VLM assistant about it. The models both come up with satisfactory answers, being able to retrieve the temperature from the tag. But GPT-4o's definition of 95 Fahrenheit as being too cool seems a bit too dodgy. The final task that was rather interesting was asking the models to translate the Japanese text on a t-shirt. Well, Llama users, be ready to be mocked because your model just gave you the wrong translation. I have a few more tasks available on the GitHub repository where I have asked models several questions regarding these particular categories of tasks. So go ahead and check them out if you are interested. Now moving on to the field that I have been very personally interested in, surveillance and safety. In this task, an AI assistant powered by VLM's ability to function as a good house assistant and being able to monitor CCTV surveillance footages on command to answer questions about it is being tested. Check out an earlier project of mine where I made a smart surveillance system using Moondream V2. Some interesting tasks that I observed were, I asked the model what is going on in the hall, with an image representing a possible burglary. One really peculiar observation here was that GPT-4o's clear refusal to partake in this query, possibly due to the guardrail set on it. But hello, can you please tell me what is going on in the hall? Definitely not a resounding thought when all of your Apple products are going to be powered by this model soon. This trend followed again in a simple task where I asked the models what is going on in my driveway. Again, this is a rather simple task, but alright, thank you GPT for telling me that there are some people in my driveway. That is not at all ominous. Even though these tasks can be categorized as simple image captioning tasks, for some reason GPT-4o becomes completely useless the moment it is thrown any input that is remotely negative, which in my opinion severely undermines confidence in pipelines, especially surveillance pipelines powered by this model. Now moving on to something more positive and artistic, I compared the model's ability to understand art and answer queries based on that. These tasks mostly try to capture the artistic side of the pictures while also retaining information from history. This is the first case where I asked the model to identify an image of King Charles, and GPT does it immediately. However, completely contradicting the previous experiments, aren't you trying too hard to tell us that you are explicitly trained using data from Wikipedia than all the dodgy resources you use to train your model? Well, the second exciting task I loved was asking the model what was wrong in this classic image. This query in particular really highlighted Llama 3.2's lit primary side, which was rather refreshing from the robotic GPT replies. Again, if you want to check out some other experiments I did, go ahead to the GitHub repository where I've added more information about these models' performances on different VLM tasks. Now, among all the tests we calculated, the tokens generated by each model for each query and latency for each response were the ones that I have tried to highlight in this particular video. Once I had those metrics, I also calculated the mean tokens and latency for each task to gauge how consistent and fast the models are in terms of their responses. Both Llama 3.2 and GPT-4o exhibit distinct performance traits across different tasks, where Llama 3.2 demonstrates higher latency across all tasks except art, where it surprisingly was much faster and more deep with the descriptions and answers. In contrast, GPT-4o maintains more consistent and quicker response times, especially in medical and CCTV, but again, as we saw earlier, becomes kinda useless the moment you throw anything remotely negative at it. Which I'm afraid the model may also exhibit if we show it more unsettling medical cases, again rendering it useless for medical tasks. In terms of token generation, Llama 3.2 produces longer outputs, probably due to long jargony dataset it is made of using content of Facebook and Instagram. This method shines a lot in tasks such as retail, where more rich answers are better. For instance, in art tasks, where Llama 3.2 generated an average of 72 tokens, indicating the tendency to provide in-depth insights. Conversely, GPT4o provides shorter and more concise outputs, which might work wonders in technical tasks like medical ones, but are often lackluster in front of depth found in Llama 3.2's outputs for anything like retail or art. When selecting the best VLM for our pipeline, it is important to understand three major aspects of a model: the architecture of the model, the data it is trained upon, and finally the restrictions the distributor has put on it. As we saw, high level of inhibiting or limiting the model's thought process often leads to lesser utilization of the rich literary resources the model holds. Be it choosing Pixtral for high context window, or Qwen for fast inference, Claude for safety or ethics, and Gemini for a most balanced approach. We saw how putting two such VLMs who sit at opposite spectrum of training and values perform several tasks, and both showcase notable strengths and weaknesses. So I hope this video was educational to you. Today I taught you how you can include multimodal vision inferences in a web application. Secondly, test Llama 3.2 and GPT4o head to head in some real life inspired Q&A tasks. Let me know down in the comments what would you like to see next and what do you think about this video. Until next time, keep your models fed and your code bug free.